In this video, I'm just going to look at a couple of very basic sorting algorithms, and then we'll kind of look at the algorithmic complexity for them. So the first one is what's called a bubble sort process. And so the code looks like this right here. And if we use the example of an array of 5 elements that contains 3, 5, 1, 4, 2 like this, where these are the indexes right here, then we can sort of look at what this bubble sort algorithm is doing here. And so if we look at the code up here, what we're doing is we're taking in this array that contains these 5 elements right here, and then it will try to sort them in ascending order. And so we're taking this array in right here, and so we're setting I into j here, where j starts at the sort of end of the array here, and then it goes down each time. So this is going down each time. And then we have our I equals 0, and so while our I is less than j, and our I is increasing like this. So we're looking at whether the array element here is greater than or equal to the array element to the right of it. And if this is the case, then we do this swap. And so what the swap does is we start this temporary one, which is at the array element m here, where m up here is our I right here. And we set this temporary one here. Then we set the array m equal to array n up here, which we see is our I plus 1. And so that is the element to the right of it. And then we set the array element n here equal to our temp. And so we're essentially just swapping those two things. I mean, that's why it's called swap here, because we are setting this one here equal to the one to the right of it, and then this temp one was the one to the right of it here, and so then we set that to the temp one. And so we can look at this right here. So I made this table for this. And so when we're at I equals 0, then we have I plus 1 is equal to 1. And so that is where we are right here. So we have this I and this I plus 1 right here. And so j is equal to 4. And so then we are looking at these two elements here. And so we see that the one to the right is greater than the one to the left. And so we do nothing. So blue numbers mean that no swap has occurred. Then we go to I equals 1 and I plus 1 equals 2. So we're looking at these two numbers here. Well, we're looking at these two numbers here, and we see that the 1 is less than the 5, and so we do this swap. So these green numbers mean that a swap has occurred. Then we are looking at these two numbers here. We see once again that the right is less than the left, and so we do this other swap here. Then we look at these two numbers. Again, the right is less than the left, so we do this swap right here. Then we do another iteration here. So now we have j equals 3. And so we are going only up to where I is less than j here. And so now we're not going to go all the way to the end here. So we look at these two. So the 3 and 1. So 1 is less than 3. So we do the swap here. Then we are looking at these two numbers. Well, the 4 is greater than 3, so we don't do a swap. Then we look at these two numbers. 2 is less than 4, so we do a swap here. And then we just sort of do that all the way to the end. So we get down to j equals 1, which means we're only looking at these two numbers here. And so that is how this bubble sort occurs here. And so our complexity analysis, so we have n iterations. So remember, we have these j here, which is our iterations. where n is the length of the array. And for each iteration, we actually reduce the number of comparisons. So in the first iteration, we do these n comparisons here. So that's this column here. So we go all the way up to n here. Then the next one, we have n minus 1 comparisons. So that would be this, this j equals 3 column here, all the way until we get to this last one here where we have just one comparison. So the total number of comparisons are 1 plus 2 all the way up to plus n, which is approximately equal to n squared. So this is a quadratic polynomial time or complexity. So algorithmic complexity here. So that is the bubble sort process. Then there is this other one, which we call the insertion sort process. Well, this is a sort of image of what's going on in one iteration of the bubble sort. So we look here, so the 3 and 5, so the 5 is greater than 3. Then we go to the next one, so 2 is less than 3, so we flip those around. Then we look here, the 11 is greater than 5, so we leave it alone. We go here, the 4 is less than 11, so we swap those, and so on. And so we get to here for that. But you can look at that in the lecture notes, which will be linked to down below if you want to look at that in a little more detail. So then we have the insertion sort process here. And so we're looking at this same array, which has the same indexes here. And so this is the insertion sort method, which is a little bit more complicated than the bubble sort that we were looking at above. And so now we're using this key right here, which we are setting equal to this this array element, which we're starting at 1 here. So we're starting at index 1 on here, which will be our value of 5. Then we have j, which is equal to I minus 1, so that will start at 0. And so while the j is greater than or equal to 0, and while this is greater than our key, so while the j is greater than our key, then we will iterate through here. So we'll set our j plus 1 equal to j, and then our j equal to j minus 1 here. So to look at that using this table I made here, so while we're at I equals 1, so our key will be equal to 5. So remember, that is this right here. So we're looking at I equals 1. We're setting our key equal to the element at array I equals 1. So that's what we have right here. And so our j is I minus 1, so that will be j equals 0, and that's less than the key here. And so nothing will happen here. Then we go to I equals 2 here, and so our key will be equal to 1 because this is 1 here. So this is our 2 index right here, and so our key will be equal to 1 here. So we're looking at this right here. So then we first look at j equals 1, which is greater than the key, because the j equals 1 is looking at this 5 right here. So we're looking at this 5 right here. And so what we do is we set the j plus 1 equal to the j right here. And so this is our j plus 1, and we're setting that equal to what is our j right here, which is our I minus 1. So we're setting that equal to 5. So now these are both 5. And then we look at j equals 0 here, which is greater than our key, which, remember, our key is 1 right here. And so we then set j plus 1 equal to j. So our j is this 3, and our j plus 1, which was our 5, we're setting that equal to 3 right here. And then we get to where j is less than 0. So we set our j plus 1 equals key. So j is less than 0, it's -1, so our j plus 1 is the 0th element. And so we set that equal to the key, which is this 1 here. So now we are setting that to 1. And so now we see we've taken these three elements and we've changed the order of them there. So now we're at I equals 3, so the key is 4. So remember, this is the third element right here, and we're setting our key equal to that. So when we have j equals 2, this is greater than the key. So this 5 right here is greater than our key, which is 4 right there. So we set j plus 1 equal to j. And so we are setting this right here equal to our j. So we're setting it equal to that 5 right there. Then we are at j equals 1 here, which is less than our key. And so we set j plus 1 equal to our key right here. And so we are changing this right here, this 5 right here into this 4 right here. Then we go through the same thing right here. I'm not going to sort of talk us through it, but it's just the same process because, that's kind of the hallmark of an algorithm is you're just doing the same process over and over again. But we end up with our sorted array right here. And so that is what we're doing with this insertion sort. And we look at the time complexity for that. So we do the iteration for n times, where n is the length of the array. For each iteration, we are making comparisons between 1 and n. So we can do either one comparison like this, or we can do like we have over here, this full n number of comparisons. And so the complexity is therefore sort of this n times this number here. And so it's sort of on the order of n squared. And so this is another quadratic algorithmic complexity here for this insertion sort. And so I do have sort of an image right here you can look at. And so this is, so we're looking at this. So we see our 4 and our 3, so we swap that. We compare this 2 to the 4, then the 3, and it's less than all of those, so we swap all of those. Then we're looking at 10 here, and so this is greater than all these, so we don't swap. This 12 is greater than all these, so we don't swap. Then we have this 1 here, and so we compare it to each of these, and it's less than each of those, so we end up bringing it all the way to the end here. Then we have this 5, and we see that it's less than 12 and it's less than 10, so we then insert it right there. Then we do the same thing for 6, and then we finally end up with all of this sorted like that. And so we can look at this a little more concretely. So here I have our insertion sort right here. So this is the code for the insertion sort. This is for the bubble sort. And then I actually made my own algorithm here, which is actually a recursive sort right here. So this is using recursion. So see, we're calling our method within the method there to do this sorting here. So we use this temporary array here, and then we sort of compare each of these, each of the elements in our temporary array, or we compare the elements in our array, then use the elements from the temporary array to sort of swap them. So it's similar to this swap algorithm right here. So then we have our main method here. So this is just the printer class, which will print things when our unsorted is less than 50. So I'm just making several of these integer arrays here so that we can use each of these different sort algorithms on them. And so what we are doing here is we are actually going to compare these different algorithms we have up here. So my recursive algorithm that I made, then this insertion sort method and this bubble sort method, and we're actually going to compare that to the sort algorithm that is actually built into the C sharp here. So just this array dot sort right here, and we're going to compare the times for them. And so we can do a length of the array, and I have it so that it will print out things if I have this as 50 or less. So we can look at these arrays here. So this is our unsorted right here. Then this was sorted with my recursive algorithm. Sorted with the insertion, sorted with the bubble, and then sorted with the built-in right here. And so we can look at the times for that. So with my recursive algorithm, it was about 3 milliseconds here. For the insertion sort, it was less than a millisecond here. For the bubble, it was less than a millisecond. And then for the built-in, it was less than a millisecond. So we can already see that my recursive algorithm is kind of a bit slower than the other ones here. But let's try this with a much bigger number. So we will do a million, and so we let that run. And this will take a moment because there's sort of a lot going on here. In fact, I let this run for a couple minutes here, and nothing has still happened. And I'm assuming that's probably because of my recursive algorithm, which is a fairly slow algorithm. So let's close that out. We'll try something a little bit smaller. So we'll try 100,000. So we let this run, and we'll see if anything happens with this. If it doesn't, I'll probably just comment out my recursive algorithm so we can look. Yeah, see, this ended up with a stack overflow. So it's because of my recursive algorithm here. So I'm going to comment that out. So we'll have to comment out a few things here. So I will do that and just edit that out of this video. All right, so I edited out my, or commented out my recursive algorithm and ran this with 100,000. So we see with the insertion algorithm, this took about 10 seconds here. With the bubble algorithm, it took 44 seconds. With this built-in algorithm, it still took less than a second right here. So we can see that these insertion and bubble algorithms are quite a bit slower than this built-in algorithm, which I believe actually changes what algorithm it does based on the size of the data input, but I'm not exactly sure what the algorithm is that it uses. But anyway, so yeah, with the insertion one, we can see the insertion one is actually quite a bit faster than this bubble algorithm here. But anyway, these are the times for these different algorithms right here. And so yeah, by the way, this is just making an array with random numbers between 0 and 100 right here. So that is what the array is actually doing. And so this is inputting that array length for each of these. But anyway, that was just a little bit about some algorithms here. I hope you found this video helpful, and I will see you in the next one.